All right, question 45 on the math subject GRE test. I guess this is a calculus question, although to me really it feels like the majority of the work ends up just being algebra. But setting the problem up definitely involves some calculus. So what's going on here is we have these two real value differentiable functions u and v, and they're both functions of x and y. Unfortunately, x and y aren't just variables. X and y themselves are functions. X a function of u and v, and y also a function of u and v. So it kind of feels cyclical here, right? U is a function of x is a function of u, which is a function of x, which is a function of u. Anyways, what we're asked for is an expression for du dx. So as this notation implies, we want to take derivatives with respect to x. So if we steal these two equations here, x being a function of u and v, and y being a function of u and v, we can differentiate each of them with respect to x. If we differentiate x with respect to x, we just get 1. If we differentiate f with respect to x, we have to account for the fact that changing x will change both u and v. So we're going to have a sum here. Informally, we'll think about how much f changes as we change u, and how much f changes as we change v. However, u and v themselves are changing, and that's because, as stated up here, they're both functions of x. So it's not just df over du we want, it's df over du times du over dx. Think chain rule. Similarly, not just df over dv, it's df dv, dv dx. If you struggle to see where this is coming from, I think it's easier to think about it as f being a function of this function u of x. If we were to take the derivative of this composite function, the chain rule tells us to first take the derivative of the outside function, so that would turn into f prime, but leave the inside function completely alone, u of x. But then you're not done. There's a second stage to the chain rule that tells you have to multiply that by the derivative of the inside function, u prime of x. What we just wrote right here is df du times du dx. Sort of informally speaking, the derivative of the function f with respect to the variable u, treating u as a variable here, the argument for this function f, times the derivative of the function u with respect to the variable x. I don't know, I kind of prefer this notation. When I solved the problem, I did the whole thing with this notation and then transformed this notation into this notation because that's what the answers are written in. But I suspect that's just me. I suspect most people watching this video are comfortable with this notation, so I'll stick with this notation for the rest of the video. Anyways, we've differentiated this function in red. Now we want to differentiate this function in purple. The derivative of y with respect to x is 0. You can think of y as a constant with respect to x. And that might be a little counterintuitive because y is a function of u and v themselves are functions of x. So it might feel like y is dependent upon x. However, when you're taking the derivative of y with respect to x, you just put a 0 here. Because u and v are both functions of x, when I change x, there'll be kind of two components to the change in g. I'll have the change in g that comes from changing u, and I'll have the change in g that comes from changing v. The change in u comes from changing x, and the change in v comes from changing x. Again, each of these an example of the chain rule. If you can get this far, you're done with calculus. Really, at this stage, all we have is an algebra problem. All right, think 1 is equal to, a times b plus c times d, and 0 is equal to e times b, note that this is the same as this, plus f times d, again noting that this is the same as this. What we're being asked is to solve for du dx, which is b in this little translation here. If you were asked to do that, well, you might recognize that you have a d in each of these equations. So you could solve the two equations for d, set them equal to each other, then isolate the b's and get an answer in terms of a, c, e, and f. That's exactly what we're going to do. Just instead of using the letters a, b, c, d, e, and f, we'll use df du, du dx, df dv, dv dx, dg du, and dg dv. All right, let's do it. So first we notice that we have a dv dx in each of these equations. So we'll solve for that. To get this dv dx alone, I'd subtract this term over to the left side of the equation and then divide by df dv. I'd get dv dx is equal to 1 minus df du, du dx, divided by df dv. Just pushing symbols around on the page. Same idea over here. I'd subtract this term over to the left and divide and get that dv dx is equal to the negative of dg du, du dx divided by dg dv. If dv dx equals this and dv dx equals this, then this equals this. All of a sudden I'm really low on room. Maybe I set these two expressions equal to each other and copy that up on the top of the page here. Now all that's left to do is solve this equation for du dx. Well, let's see, I got a du dx right here and a du dx right here. So my big picture strategy will be to collect the terms that have these du dx's in them on one side of the equation. I don't love these kind of fractional looking things. So maybe I'll multiply dg dv up to the top here and multiply df dv up to the top here. That gives me dg dv minus df du dx dg dv equals the negative of dg du dx df dv. Here's one of my du dx's, here's my other du dx. Let's move this term over to the right side of the equation. Over here, I guess. I don't want to write this too many more times, so I'm going to do two steps in one. I'm going to factor du dx out of each of these terms. I'll kind of pull this out in front. I'll have du dx times everything left over in green. And then I'm going to divide everything left over in green over to this side to get dg dv divided by df du dg dv minus dg du df dv. That whole thing is equal to du dx. That whole thing is the answer to this question. Come over here in our list. It looks like that's answer E. Note these are just written in the opposite order. df dv times dg du. I guess technically you don't want to divide by 0, so technically you should add on this comment right here that this denominator here can't be equal to 0. If you need a little confidence boost and you were able to follow that logic, it looks like only 20% of test takers got this question correct. 20% on a multiple choice test where there's only 5 options for each question is about as low of a success rate as you're ever going to see. In fact, unless I'm missing something, there's only one question on the entire test that had a lower success rate than this question, question 45.